OK、じゃあ始めましょうか。OK, so this is, well, as you can see in the slide, this is Eric van Ziest. I don't know about the pronunciation, but
close. Zeist.
Zeist, OK. And he, is it this one or this one?
Is that me?
Yeah, I think so. OK. And he's from, as you can also see, Bitbucket, and he's here to do a talk today. And of course, afterwards, after the talk, please ask questions, right? So, 質問あったらぜひ聞いてください. Okay, so
yeah.
Please go ahead.
Okay, so yeah, in case it wasn't clear already, I'm not Kim Young. So I think Kim Young was supposed to do a talk on what sounded really interesting about AR drones and modifying those and hardware hacking and all kinds of stuff. I probably would have been in the audience right now. So he's in here. I'm not really sure why, but there was an empty slot, and I was asked to fill that up with something, which I'm happy to. But I do want to start out with a big disclaimer, as in this talk was not prepared very well. I didn't know I was going to give it, so it can be very shaky. Maybe you don't enjoy it. There are 3 other interesting talks going on at the same time. Also, this is going to be a sort of a beginner level talk, so we'll be talking a little bit about, sort of the basics of distributed development, or rather like DVCS usage. Like a lot of you, like at least some of the people I recognize from the past day, I know are probably not going to get anything out of this. So feel free to just, go to another talk. I won't be offended. It's probably not going to fill the entire 15 minutes either, which is good and bad. As on the one hand, that leaves a lot more time for questions. And so as my introduction, so I'm Eric van Ziest. I work at Atlassian, and I work on Bitbucket. So I'm a developer on Bitbucket, and I'm quite happy to spend a lot of time answering questions on, our team or the product, or it's all written in Python. So, I'm happy to talk about the architecture of the entire platform, if that is the kind of stuff that you're interested in. Or we can just go to lunch early. So whatever you want. Again, I won't be offended. And then lastly, as a sort of a final disclaimer, I'll be talking a lot about Bitbucket because I want to show you how we use it ourselves. But it could come across as sort of promotional. So if you're not here to listen to a vendor talk about their own products, then again, feel free to attend a different talk. I won't be offended. But yeah, with that out of the way, let's start off. I want to sort of talk about the what our team is like within Atlassian. Atlassian is a large organization these days. We got about 500, maybe 600 people. We got a bunch of offices around the world. I'm in the San Francisco office. That's where Bitbucket is being built. Bitbucket, for those who might not know it, is a code hosting site for Git and Mercurial. It's a little bit like GitHub, so it's a modern day code hosting site. It offers Git and Mercurial. It's free with unlimited private and public repositories, and it has a lot of collaboration features built into it. So I'll be talking about how we built that and how we use Bitbucket as part of that process. This is the team. This is a few months ago. We're a little bit bigger now. This is in our San Francisco office. So we have about 17 people, depending on who you count and who you don't count as part of the core team. And about 10 of those, I think it's fair to say, are like full-time developers. I'm one of those. And when we work on Bitbucket, because we have like 10 developers, like even though it's a relatively small team within the context of Atlassian, like some of the other product teams are significantly bigger. But still with 10 people, full-time developers, you get a lot of sort of parallel development, as in different people are working on different things. So we are pretty distributed in that sense. People working on different things and multiple different things at the same time. And so at any given time, I guess we'd be working on maybe 4 or 5 sort of large features. For one thing, like one large feature was when we added Git support. Initially, Bitbucket only supported Mercurial, so we added Git support. That would be considered one feature, and a big one. It took us 9 months. So yeah, at any given time, I guess, be working on maybe 4 or 5, like a handful of large features. But in addition to that, there's tons of sort of smaller things that we do on the side, like bug fixes, for instance. Obviously, need to go ahead as well, and smaller features. So one thing, it's a bit of a philosophy within the company to work on things that annoy you. So like you'd have your large feature work that you're working on, but in addition to that, people might raise issues or complain about certain things on Twitter that maybe you recognize and you think, yeah, that's a good point, we should really fix that. And then instead of just raising an issue and sort of forgetting about it, it's fairly common to just for a developer to pick that up, run with it, and just fix it in a few days. So like all those things add to that sort of the parallel workload. Now, it's crucial to use some sort of like a source control system for to keep all of that stuff isolated. And most of us, I suppose, will probably be working with that. It might still be fine to work on a project by yourself. It's a small project to maybe get away without using source control. Not that there's much reason for that anymore, but I guess you could. But as soon as you start collaborating with other people, you really want to look at version control. And then there is a sort of the previous generation of centralized version control systems, like Subversion and CVS, which a lot of people, most likely most people, still use. And then sort of the current generation of distributed version control systems, with Git and Mercurial, I guess, being the biggest or most well known. Now, a lot of the stuff that we do in our 10-person team with our level of concurrency sort of, I think, really requires DVCS. And you could come away with maybe trying to use something like Subversion. I mean, it does offer branching and some of the features that Git and Mercurial are known for, but they work differently and they don't work nearly as well. I know because Atlassian used Subversion before Git existed, and it was painful. The biggest thing that in distributed development is branching. So branching is the core for underneath all of that stuff, and the idea is that like your main version of your project, your stable version of the project, lives on a branch on the main branch, if you will. In Subversion, that would be or that could be trunk, for instance. And but then as you work, you want to make sure that the stuff that you're committing on, because you're working on a feature that's going to take weeks or maybe months. As you work on that, it doesn't pollute that stable version, because that stable version is what you ship out to your customers, or maybe the version that you host. And so you got to keep the two things apart. And it's funny because if I look at how we used to do code development or software development before we moved to DVCS, and I bet that this is representative for like how a lot of teams that are still on centralized control systems work, is that we almost always sort of committed directly to trunk, sort of that main line of development. And it's funny because you have to be very careful that the stuff that you commit isn't going to horrendously break your current version, because that means you can't sell it anymore, you can't ship it out, you can't deploy it anymore. And so you get into the situation where you're really careful to commit things that are going to be safe, and then hopefully at some point come to a point where you test everything and you're reasonably certain that the thing as a whole is of production quality, and then you can ship a new version. But the trick, of course, is that not always will those incremental changes that you're making be safe, and so at any given time, taking whatever is on trunk at that point and shipping it to a customer is typically a bad idea. And so instead, you want to branch off. Really, you want to keep these things completely different. And you could do something like that with Subversion or CVS, but anyone who's really tried to do that in anger, working with long-lived feature branches, has probably been in branching hell, or merging hell, I should say. Subversion makes it really easy to create new branches, but as easy as it makes it to create a branch, so hard it makes it when you try to merge it back in. And that's the biggest difference with DVCS. And so whenever we start working on a new feature, we create a new branch off of our main line. And so our main line is really fairly static, right? It doesn't get a lot of stuff committed to it. And so instead, when you make a branch, you basically make a fresh copy, if you will, of that stable version, and that's where you start working on. And everybody else does that too on their own branches. And then you can do all the testing and all the reviewing on that branch, and then when you're sort of done with it, you can decide to merge that back into your into the main line. And at that point, sort of the main line jumps, makes a big leap into a next version that, again, is stable because you've had weeks or days or whatever to test and review that new feature that you've done. And, yeah, for sure. Yep.
So when you say you create a branch, are you talking about the traditional Mercurial, you create a different repository, or are you talking about a named branch inside of Mercurial?
Well, so
My understanding is that named branches inside of Mercurial live forever, so when you create a branch like that, even when you're done shipping the feature branch, you still have this thing lingering around in your repository forever.
Yep, that's true. So there are two, regardless of whether you're using Git or Mercurial, there are two ways of doing, well, not two ways of doing branches, but there's two ways of doing isolated development. One is to create a branch within a repo, so you have a single repo and everybody has their branches in there. Or you can have a repo with just one branch, really, and whenever you want to work on a feature, you create a fork, and that fork has the same branch. That's what you work on, and when you're done, you basically pull in from that fork. Both are equally usable. Initially, before Bitbucket supported Git, obviously we used Mercurial. We used that model because indeed, as you say, if you're all working in the same repository and you create branches in Mercurial, branching in Mercurial and Git are slightly different. And in Mercurial, the evidence that a branch has existed will linger on forever. So you sort of get this, at least it feels like, pollution of your repository where anytime you've done anything, even if it's just a tiny bug fix of 2 commits, when you merge that back in, the evidence of that branch remains. But it's not entirely that bad, as in you can still live with that way of development because even though you can't delete a branch or sort of erase all evidence of it, you can close them. So I'm not sure if you're using Mercurial, if you're using feature branches, or named branches, I should say, you can close, once a branch has been merged in, you can close that branch and it basically becomes invisible. It's still there, and you can still see it, but it's invisible. If you list the branches, you won't see it anymore. So likewise on Bitbucket, it won't show up in the list of branches. And so, for all practical purposes, it is gone. And so you can use both. Anyway, so this is roughly what it looks like for us. So this is a screenshot of the commit list of our own repo. And on the left, you see we visualize that activity. So every line there represents one parallel strand of development. And as you can see, like, there are different people committing at this point, and they're all over the place, right? Jesper commits to something on that branch, and Zach creates a new branch at that very moment, and all this stuff goes on at the same time. It becomes really hard to keep track of it, but luckily Git and Mercurial do an excellent job of keeping track of that. And actually, yep. There is another page here, the branches page. So as you can see, I've tried to sort of translate this thing a little bit, as in Bitbucket is translated mostly into Japanese, and so I figured I'd show that off as well. So I can't actually read this, but luckily I know what the page is about. But so this is the branches page, which tries to create some order in that chaotic graph. So what you see here is on the repository. This is a different repository, by the way. This is the PyPy repository. It lists all the branches that currently exist, all those parallel strands of development that haven't reached it into the main branch just yet. You can see the very first line there is the main branch, and then all the other ones are things that currently have stuff going on in them. And the way that working on a branch works is that if you commit to your feature branch, with every commit that you make, your branch deviates further from the original project, and we call that being ahead of the main branch, right? So your 4 commits or 15 commits in the case of that very first branch there, you're 15 commits ahead of your main branch. But likewise, as other branches are finished and get merged into the main branch moves ahead as well. And so the number of commits that the main branch has advanced puts you behind. So now your branch is behind by 41 commits, for instance, because 41 commits have been added to the main branch since you started your branch. So at any given time, branches are mostly both ahead and behind, if that makes any sense. And this is what visualizes that quite nicely. As you can see, sort of somewhere halfway, there's a branch, the Pi3K is ahead by 2,300 commits. So it's a ton of work. And so this instantly gives you a bit of an overview of like how complex certain features are. So that clearly is a humongous thing, of course. And then eventually when you're sort of done working on a feature, it needs to get merged in. And that's where things get tricky, because obviously as soon as you merge something into your main branch, you have the ability of breaking the project. And so it's important that you write tests and all these things, and you review your code properly. And what we use to do code reviews is our pull requests. And so pull requests are something that are a feature that sort of naturally grows from distributed version control systems where all work is going on branches. And what a pull request is the act basically of you as a developer asking the project maintainer, or if you're all in the same repository, asking the person who is responsible for merging stuff in, asking them to perform that merge. And the pull request then comes with a complete diff of all the stuff, all the work that you've done on that branch. And so from that point on, you can have a discussion about it, you can invite people on it, and do all that work. To create a pull request, there's a big pull request button on every repository. You just hit that thing, and you see something like this. So here at the very top, you see the two branches, or basically, the two things that you want merged. So on the left side, you see the branch and the repo that branch lives in that you want to be merged into, in this case, the staging branch of the same repo. But yeah, if you use forks, this could be between different repositories. And then you type up what you've done. So you get the opportunity to describe the changes. That's all very rich formatting. You can use Markdown, for instance, and syntax highlighting, all that kind of stuff. And then you invite the people that you think should have a look at that code, because within our team, typically, and I think that's representative for most teams, certain people naturally sort of become experts in particular parts of the code base. Mostly because when a person first writes a new feature, obviously they know most about it, and that those specializations sort of linger on as the project grows. And so at any one time, I know that when I'm editing this part of the code base, that I probably want to invite Brody to have a look at that, because I know that he knows a lot about that. And then what we aim for is to have at least two people sort of approve of every pull request before you merge it in. Approval is done by if a person reviews a pull request, they have the opportunity to like click a button to approve it, and that becomes visible to everyone. So we're sort of aiming, it's not a hard requirement, it's not enforced strictly, but we sort of aim to have a track record of having two people approve of any kind of, so you have someone to point to when it turns out to break after all, right? Blame. And then here's the pull request page. It's a big page, and it contains everything about your work that you've done. So the top section obviously you see that clear description of everything you've done. You see the list of people that you've invited. You see the branches all the way at the top where the pull request is between. And then you see things like the list of files, the diff stat basically, the list of files that you've changed, how much have changed in those files, so that can quickly give you sort of an overview of where is this change happening and how risky is it. There is the list of all the commits that you've done on your feature branch. So this is the number of your that your branch was ahead of the main branch. So you see right there, which gives you the ability to, if you really wanted to sort of open up those individual commits to see how people have done the work, like what they've done first, etc., and whether they've come back to fix things. And then, obviously, the main thing, I guess, is the entire diff. And so what Bitbucket displays here is the three-way merge diff between those two branches. And what that means is that what you see here, this diff, what you see here, is the diff that you would get if you merged it in at this point. And so when you merge in a branch, it creates a new commit, right? Because you join those two branches. That creates a new commit. And the diff that you see here is the diff between that commit that doesn't yet exist and the main branch. And it's important. It's different than what most other code hosting sites do, including the biggest one. But this is the actual thing that you would end up with, which is not necessarily identical to all the work that you've done on your branch. And so, for instance, if you've done a bunch of work where you changed this thing, but on the main branch that thing was also changed, then there's really no difference anymore. Obviously, you've done work, but there's no difference between you and the main branch. And so, do you want to see all that sort of cruft, all that noise that isn't going to change anything in the main branch? Probably not, because you don't need to review it. That already exists. So this is the differences. That's not necessarily the cumulative list of everything you've changed. It's all difference. It also captures conflicts. So if there are conflicts which means that your code cannot be merged into the main branch because you have modified a particular line in one way and somebody else has modified that same line in a different way in the main branch, you need to consolidate those changes. It can't happen automatically, and that will show up in this diff. You can view that sort of unified, or you can see it like this, as more of an IDE-style side-by-side diff interface, where you get those scrolling panes left and right. Can be easier if you you have diffs where the changes iterate between red and green, red and green, red and green. It can be really hard in your mind to separate those two, so you can alternate between those two views right there. And then obviously there is inline comments, and you can leave comments on any part of the pull request. And so here's something that you can see a thread, right? So you can have discussions with people in a threaded way on particular lines of the code. And typically what happens is that people will look at your code and say, well, that's nice, but you really should have done it differently, or this is just downright wrong. You should do it differently. And then as you can see here, that eventually leads to in this case, me agreeing that yes, you got a good point. We should probably do it differently, and that then typically leads to rework on the branch, right? So you're not done yet. The pull request, once the pull request starts, it's sort of the start of an iterative process that starts from that point on, where you keep changing the work that you've done before it actually gets merged, and that's what pull requests add in terms of value. And so as you keep modifying the work that you've done on your source branch, you go back to your local environment, right? So you switch back to the feature branch that you worked on previously, you make the changes that you agreed upon, you commit those changes, and you push that back up. Yep.
I just keep wondering, do you really have a person named Jesper Barkhouse?
Yes, well, what can I say?
Is that really his last name?
That is not actually his last name, just like that avatar is not really me, but Doc Brown. But yes, this is our actual instance, so this is how his name displays. Jesper is the founder of Bitbucket. Yeah, that's his twisted sense of humor. So you go back, you do that work, and you commit it, you push it up. As you push it up, obviously your feature branch gets further ahead again, and the pull request gets updated to reflect those changes. And so the pull request becomes sort of a live thing. It's not a static thing that you either press yes or no on. It's sort of it's a platform where you start collaboratively improving the code before it actually gets merged. And then finally, some of you might not be able to read this. I can't read this either, but this is this is the place where you can accept a pull request, you can merge it, or you can reject it, decline it. If you merge it, then the site will go on and create that commit, perform that merge that it already did, obviously, because it showed you the diff, but it wasn't made effective yet. So it goes in and performs that actual merge, and all of that stuff is done on the site, so you don't have to do anything locally. Or you can reject it, and rejecting it basically means that the pull request doesn't go anywhere. The pull request turns into sort of a terminal state in that it cannot be modified anymore, it cannot be accepted anymore, but you can still see the work that was done on it. So you can still see the diff, you can still see all those commits, even if the person later goes on and removes the work from the repository. So it's sort of there as a record that this stuff happened, and there was a discussion about it, et cetera, but it can't be merged anymore. And then another cool feature is that sometimes when you're reviewing a pull request, you're not sure about what the person did, but you do know that there's another person on your team who's really much more of an expert in it, and so you want to sort of pull them in and have them take a look, even though they might not have been added as the original reviewers to the pull request. And so you can do that with mentions, which works just like Twitter, Facebook, all these other things, where you just go ahead and say, how the hell does this work again, Brody, and you type it like this, select the name, and then they automatically get an email notification about it that contains the comment that I just made, including if it was an inline comment such as this, it contains the section of the diff with all the colors and everything, and so then they can either come to the pull request right away and respond there, or if the little section of the diff that was in their email tells them enough, they could even just directly reply in their email client and saying, oh, that's fine, that will have no effect on the rest of the code base, so go ahead. So like we use this functionality a lot, like really a lot, and again I think it's probably something that applies to other teams as well, because if you have a larger team, the larger your team is, I guess, the more you get those specializations of some people are sort of more front-end people, some people are more back-end people, somebody know nothing about SQL, etc. And so you end up having to sort of make sure that the right people look at it. And the creator of the pull request might be new to the team and might not know all that stuff. So it just makes everything a little bit quicker and easy. And now, so again, so the whole thing is that often, almost always, there's rework involved on a pull request. Now you can go back and do it on your local machine, but that typically means that you'd have to switch context, right? Because you started a pull request yesterday, waiting for feedback. You're not going to wait there, obviously, and so you're going to work on something else that you're also working on at the same time. So you're going to switch to a different branch, you're going to be in a different completely context, and then this thing comes up and you have to modify it. So you'll have to somehow shelve your changes on one branch and then switch to the other one, do the work, commit that up, and then move back again to what you're actually doing. Can be a bit tedious, and so one thing you can do is you can just edit stuff online right away in a pull request. So there's that same line again, and say I wanted to edit something. Instead of doing all that stuff locally, I can just press edit right there, and the file becomes editable on the site. And I can make the changes there, and press commit, and that will automatically do basically all that work that I otherwise would have had to do locally, but it will do it on the site. So it will create a new commit on my feature branch. It will update the pull request, and all this stuff will become visible. Gotta be careful here, because that's the commit dialog, so you can type your commit message. You gotta be careful here because that's a really bare bones editor, so it's very easy, especially with actually not especially, it's going to say with dynamic languages, because it was brought up earlier today, but obviously this applies to any kind of programming language. Very easy. There's no compiler at this point. It's very easy to screw up your code, but at least it's there. So yeah, I think this works really well. So DVCS with the right tools on top of it, doesn't necessarily have to be Bitbucket. There's tons of these tools. But starting with a DVCS, using branches a lot, combined with some sort of code review process around all of that, gives you a lot of control of making sure that you can have many people work on the same project without jeopardizing the stability of your product. Much more so than you could do 10 years ago, or at least it would have been harder 10 years ago. But still, like in our case, everybody has full access to the repository. Anyone on our team has full write access, in fact, full admin access on the repo. And so all of us could reject a pull request or merge a pull request, or even merge stuff indirectly without even issuing a pull request. All of that we can do, and we sort of trust each other. We're all sort of on the same skill level, but it's not necessarily the case for every team. Also, it's possible that maybe your team has contractors, external people that need to be able to do some work, but not accidentally or deliberately mess up the main branch. And so to take it one step further, we have branch permissions or branch restrictions, whatever you want to call them. And so on a per repo basis, what you can do is you can limit the freedom that people have making changes to it. So even though all these people have write access to the repository, so they can push to it, you can narrow down as to what changes are acceptable. And so what we have done here is that, for instance, I have claimed all the branches that start with Eric. I've claimed those as my own. And so only I can make changes to that branch. So only I can push to it. And only I can delete those branches. And so some other people on the team have done the same. But they can be very powerful if you've got external people or maybe new people that you don't want to accidentally screw up things. Now, similarly, you can prevent the deletion of branches or rebases, which is sort of advanced. So what we've done is, again, in our case, it's more of sort of to prevent accidental damage. But so we've prevented production and staging those branches from ever being deleted, because those represent our main stable product. Yeah. So so you've got branches, you've got pull requests, you've got code review, you've got branch restrictions, you get a lot of tools. But even then, and unit tests obviously, but that's not covered here. But even then, we go we go one step further, and most teams I think do, especially with hosted products, and that is we have a separate environment. We have an entire copy of Bitbucket running on a different domain that we use, that is completely independent of the real bitbucket.org. And so what we do is we continuously, because we have so many things going on concurrently, we merge pull requests in on a daily basis, multiple a day. And so whenever we merge a pull request, whenever we merge that in, it immediately gets deployed to our staging environment. It's not visible to anyone else, but and so consistently, multiple times a day, that thing gets updated. And if there's any sort of regression that somehow escaped the testing and the code review and all that kind of stuff, and it's going to break the site, at least it's going to break our site and not the main site, right? So there's a lot of deployments going on there continuously, and then once a week we deploy our staging version to production, and that process is really trivial because at the end of the day, those two environments both have their own branch. So the staging branch is what we consistently merge into, and that is the version that our staging environment runs on. And then we have a production branch that only once a week gets changes merged into it, and that is our real version. And so deploying is really simple because all we need to do is basically just merge the staging branch into the production branch and restart our web servers. So you get yet another level of protection, hopefully. Now then, I know. So again, this talk was not specifically designed for PyCon. So anyway, so there is we have a desktop client as well. Not everybody will be very proficient on the command line. Certain things, even people that are very good in the command line, still certain Git operations can be a pain in the ass on the command line, even if you do use it on a daily basis. And so for some things, like a GUI client might be better. So there is one, and it's free. And that sort of concludes my talk. We didn't do too bad, but we have 15 minutes left. I am happy to go through questions, or I could talk a little bit about like some of the architecture that might be more interesting, the architecture of Bitbucket, or just have an interactive discussion.
So, any questions? Should someone? Yeah.
So 2 questions about staging. How do you deal with database migrations when you push from staging to Bitbucket, or just that whole thing in general? And who's actually hitting staging? Is it a percentage of your user base, or is it internal only?
Right. So it's all written in Python, all of Bitbucket, and it's a Django app. It's a pretty vanilla Django app. We use almost everything in Django, for better or for worse. And so we use South. And so our database migrations are just South migrations that we've been using since, I think, about 3 years, and we've run into all the common pitfalls with South migrations, and so we've become fairly good at knowing what we can do on a live database, what we cannot do in a live database. Obviously, we can't delete columns, but we can always sort of make incremental changes. If we add a new column, we have to make sure that there's no default value, things like that. Like they have broken many a deploy. So that's one part of the question, I think. And so the other is your staging environment. How is that used, or by who is that used? Purely by us. So just the 17 people in our team use that, and only use that, whereas the rest of the company uses the real Bitbucket.org, right? So like Atlassian is about 500, 600 people. So most of them are using the real version of the site, as in they do not contribute to better sort of testing or shakedown of those new features. Now what we do have on top of this still is that we release a lot of things as sort of dark features, right? So when something is sort of done and it did survive staging, it goes into Bitbucket.org. It's still not visible to anyone because we can enable it with a flag. And so we use this for a lot of things that when we roll them out, like branch permissions was one thing. We roll them out on production, but it's a fairly complex thing, branch permissions. And so we turn them on for all of the Atlassian staff, which is 500, 600 people. And a good part of those are developers. And so they can start using it, and then there's more iteration on top of it, and then we release it.
Any other questions?
Now then, there's one thing I do want to mention. So as you can see, like some of the screenshots are sort of Japanese, some aren't. So the way that we I can't control this. So the way that we do internationalization on Bitbucket is it's all crowdsourced. We have a small team. We don't speak Japanese, and it's a hassle to do all of that, or at least do a lot of languages, have them translated professionally. And so everything is crowdsourced. We use Transifex for that. It's just an online website. And so all the translations that we have on the site right now, which I think we have about 8 languages, are just all that stuff is being translated by users. And so I don't speak Japanese. Nobody on our team speaks Japanese. So maybe the Japanese translations you see here are really crappy. I have no idea. But if they are crappy and you want to contribute, all you have to do is sign up for a free account at Transifex, and you can start updating. You can even get notifications that as soon as we deploy a new version, you get a notification that there are new strings to be translated. So if that stuff is important to you, and if you think that the quality is bad, you can just step in and make it better.
Okay, so if there are no more questions, then let's go to lunch.
Sweet. Thanks.
Okay, thank you.
Okay, guys, I think some of you might have gotten confused because the timetable that is being pasted at the door has the time mixed up. Actually, we were supposed to start at 11:10, but the timetable has been changed. It was still at 11. But lunch is from 12. You can get it from the cafeteria. Lunch is from 12 until 1.